Good morning, I'm William Silva. Chris Evans will be up here shortly. We're part of the senior management team here in Portland for Swinerton Builders. Swinerton Builders has been in business for 130 years and serving the Oregon markets for 45. We have a proud heritage of being a builder, and we are currently licensed in 50 states, but we have 15 offices and focus our services in the West and in the Southeast. We have 13 core markets that we serve, and what we're excited about is the fact that mass timber and CLT, we see that as kind of transforming several of these markets in the coming years as we see increased application and understanding of the product and its strengths. Today we're going to be talking about First Tech Federal Credit Union and their Oregon corporate offices out in Hillsboro, Oregon. It's 156,000 square feet, the largest known CLT mass timber structure in the U.S. We had a significant schedule challenge for the project, needing to complete the project in 14 months, and that included not only the construction of the structure, but all the interior build-out and 17 acres of site development on the project. Key to that success has been the schedule advantages we've realized in the structural frame, taking 15 weeks for the structural frame, of which 12 weeks for the mass timber element. As we work with clients here in the Northwest, a lot of our clients are really focused on real-world measurements of projects, including carbon footprint and carbon neutrality. But at the end of the day, you can come up with the calculator and understand the measurements, but the one that always catches everyone's ear is really that the Oregon timber regions regrew all the wood we used in the First Tech project in 46 minutes. It's just a great elevator talk, right? So as we look to the next level, that's really kind of the cornerstone of our success. We look at the old is new again, the master builder concept, and this is something that we find is kind of key to the project. We live today in a market that is really become dysfunctional, and a lot of that is mired in redundant processes where we are siloed in our communications that kind of break down on role definition of who we are and what we're contributing to a team. It just really leads to a lot of inefficiency. So the cornerstone to our success on the First Tech project was, regardless of the fact that we had a conventional CMGC contract and the architect had a conventional design contract, we chose to deliver the project differently. What we really focused on was seeking a vertically integrated team where we all sat at the table together and looked at each other with truth, trust, and transparency to really address the challenges of the project to maximize value for the client. And it really yielded the 1 + 1 = 3 scenario. And so that was really key to the project. For this project, our team and kind of core trade partners were made up not only of the traditional seats at the table of the architect, Hacker Architects, as well as Kramer Galen on the structural, together with MEP design, but really kind of the trade partners we sought to leverage and bring specialized expertise, including StructureLam, who we have here today, as well as Glumac, Apollo Mechanical, and OEG Electric. As we look to the vertically integrated team, it's really about specialized expertise and really focusing in on leveraging knowledge. And that first started to reveal itself during concept, because I think a lot of, even what Xander alluded to just a little while ago, there's kind of this forced nature of looking at mass timber and CLT and trying to force it into a structural grid that, you know, how can we make it like structural steel? Well, it's not. It's really about tapping into and understanding the strengths of the product and optimizing span, details, etc., in delivering it through. So no longer looking at a standard steel bay at 30 by 32, splitting it to 15 by 32. It's really looking at what kind of a panel are we trying to optimize on, what are the benefits of it. And what you see here is how that frame became something where we went to 12-foot spans. We were able to go to a CLT 5 at a 139 millimeter and really optimize the design. And it ultimately yielded elimination of perimeter beam, which allowed for daylighting opportunities that the architect was able to take advantage of and really bring it forward. And so as that foundation of process and understanding that opportunity with that vertically integrated team to bring those ideas forward, it really set the course for the team. So Chris is going to go into a little more detail.
All right, thank you, William. When we started off this job, William called me one day and said, I think we're going to go to mass timber. And I immediately said, awesome, we're going to build it. So we figured out a way to self-perform the erection of the building. And our big goal at the beginning was to say, how can we take advantage of the prefabricated element of the mass timber? And not just prefabricate the mass timber columns and beams, not just put the hardware on in the factory, but how can we prefabricate the mechanical, electrical, plumbing, fire sprinkler trades, and try to speed up the entire construction process. The first thing we heard is mass timber is really quick. You can go quick. But everybody was kind of focusing on the timber and not necessarily focusing on the follow-on trades. So we set up at the beginning with OEG, with GlueMac, with Apollo. We said, how can we get to a place where we prefabricate everything, pre-drill the glue lam, and set up the project for success that way. So here's a good picture of the BIM model and of the actual construction. And what you'll see is we're saying at the top BIM for fabrication. Most of the processes I've been involved with before have been using BIM for clash detection and for coordination. And we said the mass timber is going to be built with a model so that we can fabricate from it. Let's do the same thing with everything else in that building. What you'll see is and I'm used to walking around and talking, so it's hard to be located right here. What you'll see is there's pre-drilled holes through the CLT and through the glue lam beams. That was all pre-drilled in the factory. We had over 4,200 pre-drilled holes that had to be coordinated before we hit go on producing the timber. What that also meant is we had to go and model all the stanchions for the raised access floor, make sure we have the coordination set up so that we weren't putting penetrations where we had supports for the access floor. So here's how it played out in the field. If we have an electrician who has to put in a penetration and drill it 3,200 times in the building, he's going to come out, they're going to do layout. They're going to find out where the grid lines are. They're going to have a layout drawing, mark each hole, drill the hole. They're not going to drill it perfectly every time. There could be the opportunity for mistake. By doing it in the factory ahead of time and coordinating that all in the drawing, we're assured that we have that quality check over and over in the shop drawing process. The savings we get is at the end of the day, we can have an electrician out there during a peak market, during a time where there's 100 calls in for electricians every day. We can have a person out there with a garbage can full of these prefabricated electrical boxes with conduits, and they don't really have to think at that point. They just have to go in and stuff a conduit with a box into a hole and put that prefabricated element in. What that really means is their time on the floor is a lot quicker. So you've produced this mass timber building, you've erected that fairly quickly, but now you're coming in and your follow-on trades are coming in a lot quicker to do their work. You can also see a prefabricated plumbing tree that's there as well. So we were trying to figure out, how do we get to schedule certainty? How do we think outside the box? And here's the footprint of the building. It's a 30,000 square foot footprint and 5 stories tall, type 3A building. Conventionally, you would come in and just say, we'll build the whole thing up 1 floor at a time. and 15 weeks later we'll put a roof on, we'll be dried in, then we'll start our interior work. What we decided to do instead early on in the process, because we had a end date constraint, we had to not only build it in 14 months, but we had to be done by a certain time because the owner had some holdover costs. So we divided the building up into 3 sections, 3 10,000 square foot plates, and we treated the building like a 15-story building. So we did 10,000 square feet in section A. We did the next 10,000 square feet in section A. We broke apart all the shop drawings similarly. So there's section A shop drawings, section B, section C. So we could take the detailing off the critical path, and we could do the stuff that's repeatable just going straight up. What that meant is we could start a flow of work consistent with high-rise construction, where you have another trade coming on each week following you through this building, and you can get a smaller crew started earlier. You gotta keep in mind, we're at the peak of a construction market. Everything's really busy. Workers are hard to find right now. Next thing we said is, how do we control risk? Most general contractors control risk by writing a piece of paper and assigning the risk to a subcontractor. We took the opposite approach. We said the best way we can control risk on this is to own it 100%. Let's self-perform the work, let's learn every detail, and let's figure out how we can work with the design team, work with the structural engineer to optimize the details so that we're all about the speed of construction and it can go in as effectively as possible on site, and we can help reduce the cost and make mass timber a viable solution versus a structural steel frame. So here's a picture of kind of halfway through the job. Right at this time, the green area on the left, that's area A. Those shop drawings were 100% done. That part of the building was being erected. The area in the middle, part B, those shop drawings were just under review and almost ready for production so that we could have just-in-time delivery of the fabricated materials. And then you can see in area C on the far right that we had gotten done with the structural steel shop drawings, but we were still working on the mass timber components. That was the power of kind of breaking this building up and treating it unconventionally. The other thing, from all of this, what you can see is 90% of the work, all the glory is out there. You watch it get erected, you're like, oh, this is awesome, and it's really neat. How do you install it? But 90% of the work getting to an effective and efficient installation is by pre-planning, working through design, working with shop drawings, and being a collaborative team with all members. So what we did when we were looking at speed of construction, we looked at some past projects in the area, said, okay, typically these are going to be a knife plate on tube steel connection. That's how the beams are going to come together. And then we worked with our partners at Structurelam in a design assist capacity with Equilibrium Engineering to develop and come up with a solution for the hardware connections with a double Ricon solution, and our partners at MightyCon as well. The reason we chose this option was because of the time constraints that we had. This was really easy to put in the field. There's no field fabrication required. It all came out 100% attached to the glue lam, and we could just focus on erection and erecting pieces and not doing any on-site fabrication. Thank you.